Good morning. Or actually good afternoon. It's Sunday at 1:21 p.m. And I noticed I got a flurry of questions. So thank you very much for more questions. I got a nice cup of tea and I'm going to answer your questions. This is part deux. And I'm going to answer as many questions as I can. And if you send me messages via GChat, if you're set up for Hangouts, make sure that you send me a message to confirm that we're all set up well in advance. So what I intend to do right now is to kind of go backwards in the questions that have come up, and hopefully I get to everybody's questions. So one question says, say we have an almost non-existent effect size and an N of 30, which results in a very low statistical power. The p-value ends up being 0.8, so we fail to reject the null. However, if we increase N to 30,000 and assume the effect size stays the same, the power becomes almost 1.0, meaning that it would be highly likely that we would reject the null, given that it is false. Does that mean the result when N was only 30 was likely a type 2 error, or is it that not as assumption we can make? Or is that not an assumption that we can make without actually running 30,000 people through the study? Good question. So as I said before, power is a function of sample size, effect size, and alpha. And as sample size goes up, so does power. Now, think about it this way: it's a probability, okay? Just like a probability that it's going to rain. I woke up this morning and I noticed in the forecast from last night that the probability for rain today was very low. Now, that doesn't mean that when I step outside and it's raining, that they're wrong. It just simply means that the probability given those parameters are such that it's very unlikely to rain. Now go back to hypothesis testing. With hypothesis testing, it's a projection. Okay, so if I say to myself, what's the probability of me rejecting the null and being able to celebrate my findings at the pub, given that I have a sample size of 30 and a very, very small effect size, non-existent in this case, or vanishingly small. It means that there's a very low power given those parameters. Now, if I stick with those parameters but just change the N and I move the sample size up to, in this case, 30,000, 30,000 gives me a much higher likelihood of rejecting the null. But when I fail to reject the null, it doesn't mean that there really is no effect necessarily, but it also doesn't mean that there is that the probability or the power is incorrect. It just means with 30,000 people, there's an incredibly high probability of rejecting the null. And you'll end up rejecting the null in many cases when the null is indeed true. And in this case, if I have a non-existent effect size, meaning that according to Omniscient Jones, there really is zero effect size, then chances are if you reject that, then what you're doing is you're committing a type 1 error. Your power is sufficiently large enough, 30,000 people, your power is sufficiently large enough, and it was so powered, so highly powered that you rejected the null, and you rejected the null that really shouldn't have been rejected. So I know that this is kind of a roundabout way of answering your question, but the assumption is that we don't have to run 30,000 people as a counterfactual or as a hypothetical. We just have to pay attention to the fact that these are the parameters that we have going into our study, that our study has this N size. And in many cases, the effect size isn't known. We have to look at the literature, or we have to take a guess. It's a swag, a scientific wild ass guess. And when we do that, we'll have an idea about what's the probability, kind of like what's the probability that it's going to rain, but we'll get a what's the probability of us having sufficient power to reject the null. Okay, now, why do we care about power after an experiment has been done? Very similar, okay? That is, if we've already have an observed effect size and have already rejected or failed to reject the null hypothesis using hypothesis testing, what uses it to calculate the probability of a, quote, success? Excellent question, and it actually follows from the first one. is that more often than not, we want to calculate the power after the fact. Usually it's a good idea to calculate power if you fail to reject the null. Why? Because you want to know if you fail to reject the null, if that was because simply that you didn't have sufficient power, and you're more likely to commit a type 2 error. So what we really want to know after the fact is, geez, did we even have a fighting chance to begin with? That's why we calculate power after the fact. Okay. All right. Third question. Do we have to use the data provided, or can we use our own data? You have to use the data provided, period. To what extent do we need to discuss the different types of validity and reliability? To what extent? You have to use your judgment. Remember that it's your story. You have to tell the story, go into as much detail as you think is required in order to communicate what you know. If you go too deep, you have a long, winding road that's very boring and too much detail. It's like reading an encyclopedia to me. Okay, tell a story, show me that you look like a student that actually knows this material. Okay, I feel comfortable explaining the concept of validity and the challenges associated with trying to measure it, but I'm having trouble understanding the software validity analysis requirement. Apparently somebody is trying to get in touch with me. Oh, that's Amazon. Thank you, Amazon. Sorry. Let me start over. I feel comfortable explaining the concept of validity and the challenges associated with trying to measure it, but I'm having trouble understanding the software validity analysis requirement. I've used the item exam function in the psychometric package, but don't completely understand the output. One column gives me a bunch of other stuff. Okay. So I chatted with one student who was kind enough to give me some output and all of that, and asked for a little bit more explanation. And here's what I said, and it turns out that a person, the next question is along the lines of the psychometric package. There are nifty results, as one of the students said, provides a nice nifty table, including each X value and all these things. Okay. These packages are not vetted by anybody other than the author. So be careful if you're going to use this. There's one way in which you can always get the output. You can get the output of and the actual function that's being used by just typing the function name without the paren, and it will give you all of the code, and then you can take a look at it. I don't use the psychometric package, so I can't really comment about it. I did go through some of these details for the student who emailed me directly. But rather than say much about that, let me just step back and talk a little bit about the validity. Remember that validity computations are actually pretty straightforward. They're almost in all circumstances correlations. If you learn one thing, you've learned how to calculate a correlation between two variables, piece of cake. So all you have to do is calculate the correlations between two variables, and that will be a type of reliability, or a type of validity, excuse me. It can also be a type of reliability, as we've learned. So, you choose how you want to do it, but please explain what you know of validity and what that correlation may represent. Okay, the software side of things here for this module are actually pretty easy. There's nothing, in both in SPSS and R, it spits out all of the details for you. You just have to explain it, okay? Don't overthink it. It's not that complicated. Validity analysis, the reason why I only took about 20 minutes to explain validity is, in terms of software, there's not a lot that you can do. In almost all instances, they are going to be correlations. There are instances where they're special correlations called point by serial, but we won't get into that. If you want to know more about that, please come and chat with me, okay? I'm always interested in chatting more about this stuff. Okay, I think that's it. Multiple formulas available to use. Remember, use assigned readings as well as optional readings. Great stuff there, okay? So just take a look at that. All right, that's a 10-minute Q&A session to go over the last, I don't know, 5 or 6 questions that were sent my way. If you do have any other questions, please email me. If you think that they are of general use to the entire class, feel free to email the entire class. I'm happy to do a reply to all. Okay. I hope you find that this was useful. Also, I have another video to post, so stay tuned for that. It's perfectly imperfect with some incorrect things in it. So it'll be good for you to watch this. And I'll tell you at some point why it's important for you guys to watch people who don't know everything, because you can pick up on the things that you do know and the things that you don't know. Okay. Thank you again for your attention. Now I'm 11 minutes. It's Sunday afternoon. Have a lovely evening.